Now that you've come from my other video, explaining how differentiation actually works and what the heck it even is, you don't need to go through all that arduous and tedious process of finding the slope manually. We call that differentiation by first principles, because it's the first principle, I guess? I mean, it defines differentiation, so it's not going to be like the seventh or anything. So you don't need to do that every single time. There are 4 rules for polynomials and 3 rules for what I like to call weird functions. Here are the 4 polynomial rules. The addition rule says to differentiate some function, if you're adding or subtracting 2 distinct terms, you can differentiate them individually. The constant term says that anything that doesn't have a variable attached to it has a slope of 0. Differentiating the number 5 returns 0. The coefficient rule says that to differentiate a function multiplied by a constant, you can actually put the constant outside of the differentiation and not touch it at all, and the result will still be correct. The power rule says that if I have x to some power, I can multiply x in front by this power and then take the power down by 1, and that's the derivative. Like how we looked at the example of the function x squared, I can multiply it by 2 since that's the power, and then I bring the power down by 1, so the derivative should be 2 lots of x. From our video, we showed this was in fact true. These 3 rules for weird functions are the trigonometry rule, the exponential rule, and the logarithmic rule. The trigonometry rule says that derivative of sine is cosine. The derivative of cosine is negative sine. Logically, the derivative of negative sine is minus 1 times by the derivative of sine as per the coefficient rule, so the derivative of negative sine is negative cosine. Same logic, the derivative of negative cosine goes full circle and returns us to sine basic. The derivative of an exponential, e to the power of x, is just e to the power of x. It's its own derivative. For a different base a, becomes a to the power of x times by the natural logarithm of a. The derivative of a logarithm of x is 1 over x. More broadly, the derivative of something inside a logarithm is the derivative of whatever's inside that logarithm over the original function inside that logarithm. Keep in note this applies to natural log. Sorry, I should have specified that. These 7 rules apply to single functions. There are also 3 rules though for when we're combining functions, which happens quite a lot actually. The product or multiplication rule says that the derivative of 2 functions multiplied together is the derivative of the first times the normal second plus the derivative of the second times the normal first. The quotient or division rule says that derivative of 2 functions in a fraction is the derivative of the numerator times the normal denominator minus the derivative of the denominator times the normal numerator, all divided by the original denominator squared. Unlike the product rule, which you can do either way, you need to emphasize that the first term has the derivative of the numerator, not the denominator, and the minus is quite important. And the last one, probably the most important one of all, is the chain rule. If I differentiate some function with another function entirely inside it, acting as the x, in a way, of the outer function, the derivative is equal to the derivative of the outer function without touching the inner function, all multiplied by the derivative of that inner function. That's about it. And this allows you to differentiate pretty much anything you get thrown your way.